Okay, next section. Let's go to number 10. Hey, you know number 9? Number 9's a little crazy. Here's the answer to number 9. And you know what? It just takes a little bit of juggling numbers around, and you got to realize that when you multiply these two together, I think you get like, I don't know, like 18,000 something. And you just got to juggle numbers around, and it's divisible by 33. There will not be one that crazy on the test, all right, with those large of numbers. And so let's go to number 10. Number 10, the answer looks just like this. But let's try to see why the first thing you have to do is you have to double check on number 10. Is there a number that all three of these are divisible by? You want to ask that question every single time, but you got to kind of check, because that's going to make your job a little easier if you take that out. Looks like you can divide by 2, divide by 2, and divide by 2. And then you're going to rewrite it this way. Take a 2 out, and so that turns into be 9 squared plus, what is that, 52 and minus 12. Okay, so then we're going to actually factor this piece, kind of ignore the original. You don't have to cross it out necessarily, but then we are going to take this piece and factor it so that it finally kind of looks like factored into two binomials. Okay, so what we want to do is take these two terms right here, this 9 multiplied by 12. What is 9 times 12? 9 times 12. 108. Okay, then you're going to take this and you're going to go 108 right here. And then you're going to add them, two numbers that multiply together to give you 108 and two numbers that add together to give you 52. But wait a second. This is negative right here. So it needs to be a negative 12, which also turns this into a negative 108. So that needs to be a negative number. In order to multiply two numbers together to give you a negative, I know that one of the numbers needs to be negative and the other number needs to be positive, because a positive times a negative gives me a negative. Okay, so really, if I add a positive and add a negative together, what I'm doing is finding the difference between the two. So I'm going to write down this word right here, difference. So you recognize that as we find combinations or multiples, I really want the difference between the two numbers. Okay, so let's think about this. We got 1 times 108. Difference of 52? Nope. 2 times 108, or 2 times, what is it? Half of 108 is 54. What is the difference between these two numbers? Aha, 52. So see that I didn't have to go too far in terms of my multiples in order to figure out what combination works. Now I have to ask myself, do I want 54 minus 2, or do I want 2 minus 54? I have to know, do I want to put one of them here or one of them here? I want to know what order to put them in. So how am I going to get 52? Positive 52? Well, I got to take 54 minus 2. So we're going to put a 54 right here, and we're going to put a 2 right there. Okay, that helps me over here. I'm going to just kind of assume that 2 gets translated to my answer down here, which my answer is going to be a binomial times a binomial. So I can make the parentheses for that right away. Then I take this piece right here, 9n squared, and I'm going to insert these two numbers to make a combination of 52. But I ask myself, what piece do I want to put with the 9, and what piece do I want to put with the 12? So I'm going to go plus 54, because 54 and 9 actually have something in common. And then I'll go minus 2n from it. And then minus 12 gets tagged along down for the ride. Okay, then I group it up. So what I'm going to do is I'm going to group this, and I'm going to group this. Now remember, you have to put a plus sign between these two because you still want addition between the two. Okay, then I'm going to factor out a piece out of this first term. So that means take a 9 out front and an n out front. So 9n. And I'm going to take out, and then I divide this by 9n, which leaves me with an n left over. And what's 54 divided by 9? Plus 6. And then you divide off an n because it comes out front. So we have n plus 6. Okay, let's think about this other one. This is a negative and this is a negative. So why don't we factor out a negative 2? So we're going to go plus And we'll go factor out a -2. And what's left? N plus 6. Just like that. We did it correctly if this piece matches this piece. The N plus 6 and the N plus 6 are all the same exact thing. Okay, so we're going to rewrite it. And we're going to put 9n here minus 2. And we're going to put n plus 6 right there. And that's our final answer, this last piece right down here. Remember that, hold up. Why'd I put a 5 right there? Shouldn't have done that. Put a 2 right there. See, that 2 came from right up here. So it should be 2 multiplied by the quantity of 9n minus 2 and n plus 6. Yay. A little bit of work on those, but once you get the hang of it, it's not too bad. Okay, let's skip number 11. Ask yourself, is there a number we can divide out? Yes. How about a 5 comes out front? And then there's your final answer for number 11. Okay, last one we're going to do is number 12. Actually, let's do a tougher one. Number 14, okay? Number 14, we ask ourselves, how do we get this started? Well, the first thing I want to do is we write down x equals -b divided by 2a. The reason this last one we're going to do is because all of the rest of the ones on this page are done exactly the same as this. Just plug in some values and you're going to plot your graph. Okay, so the first thing we do, this is on our board during the test. You don't have to necessarily memorize this. You just need to know how to do it or use it. So ax squared plus bx plus c is our general formula. So what we do is we find this a value and the b value and we put the numbers in here. Okay, so what I do is I'm going to go x equals, this is going to help us figure out at what x value is the center of my parabola going to show up. Okay, so I go -b and my b value is located right here. So that's 12. So I put a 12 in right where b is, and then I multiply 2 times a. A value is right here. Okay, so 2 times 2. Put that right in where this a is showing up. Okay, so let's evaluate this. This is -12 divided by 2 times 2, which is 4. So what is 12 divided by 4? Well, it'll be a -3 overall. Okay, so what I can do is I can go to -3 and I can kind of say, well, let's make a little dashed line on that because that's going to be called my axis of symmetry. This is where the center of my parabola should either open up or open down. We don't really know yet. In order to kind of figure that out, I make my t-chart. Okay, try to find a few points that'll work. Remember that how these functions work. We have inputs and outputs. My first input that I might select is this x value because I know that's going to be called my vertex. The vertex is where the center of my parabola will be. All right, and so just take that -3 and you're going to put it into this position and this position for x, and we're going to evaluate it. Okay, so I'm going to take 2 and I'm going to multiply by -3 squared. And remember, you have to square it first, then multiply by 2. So then I go plus 12 times -3, running out of room over here, plus 16. Okay, so I'm going to take -3 and square it. So that turns into 9 times 2. I'm showing a lot of extra work. You can do a lot of this in your either in your calculator or in your head kind of thing. Okay, -3 times 12 is like -36 plus 16. 2 times 9 is 18. So really just put all these together. I don't know, 18 plus 16 minus 36, and you get -2. So I write -2 right there. And so my combination is to go over to -3 on the x-axis and then go down to -2 and make a point right there. Okay, I probably could figure it's going to open up right there. So I'm going to pick my next point at, say, -1, and then maybe another one at 0. I don't know. No, 0 will be off the graph. I can already tell because that'll be 0, 16. So I'd probably pick -2. Okay, so substitute these points in, and you will end up getting a graph that looks just like this. After you've substituted a point in, you're going to get this one right here, this point, and then you're going to get this point right here. And what you'll do is you'll mirror them across your axis of symmetry to make the point over here as well, and this point right here. All right, we've run out of time again.